So we are on Unit 4, Lesson 6, and just to start off, the title's wrong. We are actually in this lesson going to learn about complex numbers. Okay, what they are, how to do operations with them, and how to know what happens when we get the square root of a negative number. So there's not a ton of real-world application of this. There are a few, but mostly this is talking about the structure of numbers and how we talk about something called imaginary numbers. So the vocabulary from those flashcards is going to be kind of important, but I'm going to jump right into the square root of a negative number. Now, if you put the square root of a negative number in your calculator, you're going to see error, right? Non-real answer or something along those lines. So we're going to talk about a special symbol we use for the square root of a negative number. So the imaginary unit I, you're going to see that. That is the square root of -1. So whenever you see the square root of a negative number, that is called an imaginary number. So this property, if r is a positive real number, then the square root of negative r is I times the square root of r. So I'm going to show that with an actual example. The square root of -3 is really the square root of 3 times the square root of -1. So if the square root of -1 is I, then this is just I times the square root of 3. So I just want you to make that connection that the square root of a negative number, you can pull out an I from that to get rid of the negative inside of the square root, okay? So for the second property, if we square an imaginary number, if we square I times the square root of E, that would be like I squared times the square root of E squared. So what I want you to remember here is I squared is -1. And if I square the square root of something, it's just that number. So this would just be -E. So I squared is -1. When I square a square root, what's left is whatever was inside that square root. So we are going to use solving that we learned in the last lesson, but we're going to get imaginary answers, okay? Imaginary numbers as solutions. So solving this equation, in example 1, I would start by subtracting 15 from both sides. This would be 2x squared equals -50. I would divide both sides by 2, and I get x squared equals -25. So like the last lesson, my final step here would be to take the square root of both sides. And we've got to remember, when we take the square root, it's positive or negative, so our solutions are positive or negative square root of 25, which is just 5i. So x could be positive 5i or negative 5i. So remember, square root of 25 is just 5, but remember when we have the negative square root, we pull out I, okay? For part B, this is similar. Subtract 13 from both sides. To start, 3x squared equals -36. I would then divide by 3. X squared equals -12. And then I square root both sides. Now here, I'm going to say plus or minus I, and the square root of 12 is not a perfect square. Okay, so we're going to have to simplify that square root. So this is remembering how to simplify the square root of 12. So I would pull out a perfect square. So this really is 2 square root 3. So for my solution, I'm just going to clean that up a little bit. This would be 2i square root 3. Okay, so it's simplifying that square root of 12, and it's remembering that since it was square root of -12, I pull out I. All right, So we'll get some practice with this, with solving. In the quizzes, I started including explanations or showing some of my work for the solution. So hopefully that helps. So aside from getting solutions as imaginary numbers, we're going to talk about sums and differences of complex numbers and then how to multiply them. So operations with complex numbers. So adding and subtracting complex numbers comes down to having a real component and an imaginary component. It's basically like combining like terms. So I'll show you that in example 2. So this diagram at the top, or this little table at the top, shows us just the steps, but I think an actual example is a little more concrete. So in this example 2, the real components are 6 and 4. So I would take 6 minus 4. And then the imaginary components are 3i and negative I. So that would be 3i minus negative I, because we're subtracting. So this would be 6 minus 4 is 2. 3i minus negative I is like 3i plus I, which is 4i. So it's just like combining like terms. That's all this is similar to. So that's how we subtract. We subtract the real components, we subtract the imaginary components. For part B, we are adding. So I would do 2 plus 7, and then 5i plus negative 2i. So combining the real components, 2 plus 7 is 9. Combining the imaginary components, 5 plus negative 2, this would be positive 3i. And that's simplified. So when we talk about standard form is real first plus the imaginary component, okay, plus the number with I. So just think the real component always comes first when we're writing in standard form. So our next example is multiplying complex numbers. So this is a little more in depth because it's like a binomial. So for this we distribute 2 through the second expression. So this becomes negative 10 plus 4i. So I did 2 times negative 5 and 2 times 2i. Then I distribute I through the second expression. So this becomes negative 5i plus, this becomes 2i squared. So to simplify this is negative 10. This would be minus 1i, or just minus I, plus 2i squared. What we've got to remember is that I squared is negative 1. So this is really 2 times negative 1. So I've got negative 10 minus I minus 2. So if I'm writing this completely simplified in standard form, this would be negative 12 minus I. So it's remembering to distribute, and it's remembering to combine those as kind of like terms, okay? Think of it as combining like terms. So this would be our simplified expression in standard form. Big thing here, I squared is negative 1. That's a big deal, okay? And then our final example has us divide complex numbers, and kind of like in the last lesson where we did what's called rationalizing the denominator, in the same way, I is a square root, so we don't want I on the bottom of a fraction. So the way I would write this in standard form, first I'm going to rewrite the entire expression. The way I would get this in standard form is I would multiply by the conjugate of the denominator, the conjugate of the bottom. So I'll multiply the top and the bottom both by the conjugate of 2 plus I. The conjugate of 2 plus I is 2 minus I. So this has a few more steps, okay? So the top, We're going to have to write out everything to make sure that we're following this, and then we can reference it later when we practice. So the top would become 12 minus 6i plus 8i minus 4i squared. So that's that double distribution we kind of talked about earlier in this unit. The bottom becomes 4 minus 2i plus 2i minus I squared. And the whole reason we do this with the conjugates is because these i's cancel on the bottom. They become 0. So all that's left right now is a lot of simplifying, okay? So the top becomes 12 plus 2i, and then negative 4i squared is like negative 4 times negative 1. So this is really like plus 4. Remember, I is negative 1, so that becomes positive 4. On the bottom, this becomes 4 plus 1, because I squared is negative 1. So that becomes positive 1. So if we're finishing simplifying the top, I'm going to combine the real numbers, 12 and 4, to get 16 plus 2i over 5. And that is as far, sorry, little bump there. That is as far as I want you to go, okay? The main thing here is if all of these numbers, 16, 2, and 5, all had a common factor, we could divide them all by something. But these don't, so we can't simplify anymore. So if this were like 16, 2, and 8, I could divide everything by 2 to simplify, like a fraction. But right now, keep it as a single fraction like this. This is good. The only other way you could really write this is you could write it as 16 over 5 plus 2i over 5. If you wanted to separate it into a real component and then your imaginary component. But for my answers, I just want you to write it as a single fraction. The main thing is I want you to see how things cancel, and we use conjugates because we're going to be using conjugates later on with some solutions. So just keep that in mind. So I think you're ready for the practice. Remember that quizzes, I'm trying to make those follow the checkpoints pretty well to prepare you. If you want to use the paper and pencil practice, keep doing that. That's fine. All right? I'll try and do a better job of posting my answer keys for the practices so that you can kind of follow them along and follow my steps.